welcome to TriRights, the new era of learning. Myself, Sheikh Abdul Rafiq, and I am your data science trainer. Okay, let's move into the topic. Today's our topic is linear regression. Right? In data science, linear regression is a fundamental technique and machine learning. It is used to model the relationship between a dependent variable target has and a one more independent variable has predictor. Right? In simply in definition term, see, the term regression is used to when you try to find the relationship between the variables, okay, in machine learning and its statistical modeling, right? That relationship is used to predict the outcome of the event, right? Whenever we are predicting some difference between the two variables, at the time we use linear functions and linear regression methods from the machine learning in the concept of data science, right? Uh, in that we also know the machine learning formula has in previous class we have discussed about the linear function equation, right? Y equal to mx plus c or y equal to ax plus b, right? Yeah, same concept here we also use in linear regression in the dependent variable and we has independent variable and we have coefficient slope and intercept, right? Mm, there are three or four types of linear regressions. In terms, we can say simple linear regression has a one independent variable. Multiple linear regression has a multiple dependent variables, and one known as polynomial regression, no linear relationship in that. Okay, like that we have some linear regressions in that we use methods like that. So see the concept. In this most linear regression, we use least square method. It is one kind of method we use in linear regression, right? For this linear regression, least square method, we consider as linear regression uses the least square method, right? The concept is used to draw a line through the plotted data points. Okay, the line is positioned in a way that is minimized the distance to all the data points, right? We called as reducible or error. In simple terms, I will explain, right? Let's move to the graph part. Okay. In simple terms, we can say as if we have any graph like this, so let's take a assumption like this. I have a graph like this. Okay. This my dependent variable has y-axis and this is my independent variable has x, right? From this through, I had a linear line. Okay. This is my linear line. Let's consider as a linear line. Okay. From this, okay, it is my y value, right? And this is my x value. Okay. From this, in this we have a balls. Let's take another color. For example, clarity. So, this. Okay, let's take blue color. Okay, right. Okay. This my plotted data. Okay, in graph. This my points were plotted. This is my data. It's recognized. It's represented in scatter. You can say scatter form. Okay. These dots are nothing but it is my data in graph, which is visualization. Okay. Now see the distance between the linear line is telling the relation of the variables, right? How both variables has a how much relation. See, the red lines you are seeing, this shows the distance of the x variable and y variable. It is nothing but least square method we can call as. The red data is shows the difference or the distance between the linear function. We can say no linear relationship or perfect linear relationship or perfect negative linear relationship like that. This red dot shows the gap between the variables, relation between the variables, right? So let us consider, okay, in simpler I can explain like this. We can go to WordPad, like, okay, linear relation, we all that known as the red dash. Yeah, see, the red dashed lines represent the distance from the data point to the draw mathematical functions, right? It shows the difference of the distance, right? Okay, let's open the VS Code. In simple terms, we make a code on it, right? To explain clearly. Okay. Now, in this concept, see, this is our graph data, right? We have imported the data here. So create a file name as linear regression. Right? I create a sorry, wait, regression.py, right? Okay. Now in this concept, we use to first in mainly for prediction data science, we use mostly for predictions, right? Linear regression is also predicting with a prediction method we use. Okay, don't confuse. Okay, now for the function, I have to show the graph like this for you, right? Now my intention is to prove the distance of the data like this. We called as this data has imperfect data, right? On the distance, see, linear function traveling, the data is dotted from somewhere. It is somewhere not proper function, not proper linear relation, right? So I'm proving that which is perfect linear relationship and which is not perfect linear relationship, right? Okay. Based on these concepts, we create a code. Okay. Now coming to the first, mainly import modules we need. What modules we will need? We use pandas, matplotlib, sciencepy. Okay. Now import it. All the cons on the libraries you want to import. Import pandas has PD, right? Now import for graph we use matplotlib. Import matplotlib dot plot has plt. Now another one we use sciencepy in this. Okay. Sorry, not import function. We use from sciencepy. From sciencepy we used to import a stats method. Okay. Now read the value. Okay. Now take the values. Now we need to input the data right from the pandas where we can check health data and we consider data to there. Mm, we know how can we import the data. We are reading since we starting. We are seeing the concept, right? Okay, now import it. PD. We use read CSV, right? Okay, let's move take read CSV and enter the data which you want to select health data, right? This is my health data, right? Health data dot CSV, right? Use the headers 0 and separate by line by comma. Okay, and giving it now declare the variables. Okay, declare the x-axis and y-axis. Okay, for x-axis I am declaring from health data. Wait. We did not declare any variable for this, so first declare a variable for it. HELT health data. This is our variable. So now take the health data. Okay, from health data I am taking x-axis as average pulse, right? I take x-axis as average pulse. Okay, and now same y equal to same. I am importing y equal to for y I considering calories burnage. Okay, first I will show perfect linear relationship, and after that I will show in a no data relationship, no linear relationship. Okay, now enter the data. Now it's complete. We use the angle x-axis and y-axis. Okay, we use the variables. This is both are my variables. X and y are my variables. Average pulse and calories burnage. Right. Okay. From this, I want to consider a for some kinds. So for that, I was to import. Not import. I can has to take or like get important keys values with important key values like slope and intercept This is my key values, right? R and P. R is nothing but R squared method, and P is nothing but P value we considering here, and STD error. This is just my key values, okay? Not functions. This is just my key values I'm entering for stats. Okay, enter stats here. Stats.a function we has linear regression, right? This is our concept function for which you are giving. I am giving x and y to these functions. Okay. In we are already discussed, right? For the function we use using, we has a slope line from to here, right? This is a linear drop data like here to here or wherever the data occurs, right? See, we have a slope here to here, we have a slope. Okay. In a where the data is triggering here, we have the intercept, right? Okay, for considering we have like take a variables, key variables. Okay, don't be confused. Now let's take the linear equation. Linear equation what we has slope into x plus intercept, right? This is our linear equation, right? Now consider this linear equation into Python function. In Python function we declare we give variables. Okay, for using the we use def concept def function here. Def I take where I give a function name as my function. Okay, I take x value. From that I'm returning the slope, I'm reading the equation. Okay, x plus intercept, I'm returning the function, right? From this function I want to map the function, right? For the listing, it return the value, but I want to map. We are using in concept pandas now, we're using matplotlib now, so I want to trigger the function, so I use a list and mapping function. I map the my function and x variable here. Okay, for this I take a list and I use a map for it, and in that I use my function comma I declare s. So keeping a variable like my model, I'm creating model now, so I take my model as. Okay, now it's considered, right? My model is considered. Now we want to arrange the scatters. After completing, we create a function, right? Here the function that uses the slope and intercept values to return the new values. Okay, we consider it, and this new value represent where the x-axis and the corresponding to the x-axis and y-axis. So, okay, wait, I will say, I'll tell you clarity. Here we created a function of slope and intercept, right? For returning the value, returning the new values. Okay, and here we are returning in my model. The new value represents where the x-axis that's corresponding to, sorry, y-axis that's corresponding to x value. Okay, will be replaced, right? Y-axis corresponding to the x values. Okay, Um, run each value for the x array through the function that will result in a new array, right? In each array we have to run a point, and that concept runs into a new array with the new value for the y-axis. We give a new value for the y-axis by using the x value. We consider a new value for the x values. Okay, for this we use the my model function, my model concept. Okay, now take a scatter for it. I consider a scatter function for x and y, and after that I considering plotting for the data. Plotting for plotting also I use same mathematical function because I am considering here my model has slope. Now I'm returning the slope, so I consider here I'm written the linear equation. I didn't consider xy. I directly giving the linear function formula equation. Okay, place intercept, right? Takes the concept. Okay, I'm returning the values. Plotting. Now PLT dot let's consider has let's use the variables. Okay. Let's use min and max. Let's use the min value and maximum value and minimum value for the x-axis and y-axis for the both values variables. We want to give max and min. Okay, y max equal to, I consider here long variable as 2000 x label. Yeah, we can take some of the x label because it's considering the heading like, okay, x min equal to here 0 and x max equal to here 200 I consider. And now take by mistake become label, so it's no problem. We take label also. For y label I consider y label and x label, right? Here for y label I considering x label I'm giving heading concept we are giving as average pulse. Okay, average pulse. Okay, sorry. I'm just want to change the data, right? On it, I want to change here. I can say y give average pulse for y-axis. Sorry, no problem. Just change the variable. That's it. Why we want to again change the code? Just change the variable names. I know it's clear. X label, x-axis I give average pulse and y values I given as Caldis burn age. Right now, what the we use PLT show. Let's see what the output will occur. The code and run. Now see we get proper linear relationship or not proper linear relationship. See, this is the proper linear relationship we get. For that I consider, wait a minute, first 1 second. Let's now see how proper linear relationship it get, because the variable has the same pattern. It's following the order, right? 80 triggers and this triggers, this. The data is in a proper format according to the linear. So now I want to consider non-proper data. For the non-proper data in health data, we consider as this is also okay. Okay, I take instead of average pulse, I take duration. Now see what's the data present as average pulse. I take instead of average pulse, I take duration here. Okay, I take duration. Now see how data is improper way. Now see here, the data is how improper. Check once. See, now I'm zooming more. See the data in between the linear line, how far away the plotted points, scattered points. See, no data is presenting on the linear line. It's all away from the distance, little bit distance is uh, away from the linear line, right? So like this data, or we have a like some other data like we get dot here. Like yesterday we no relationship concept we use now. Like the data represents. So this is considering a linear function. So we have to predict the correct value in linear regression, which is proper linear regression function, and which is non-proper, and which is perfect negative, and which is no relation linear. So it is used to finding the difference relationship between the two variables, right? Okay, I hope you understand. Okay, bye.